right. Algebra 1. This is just a test. Let's see if the mic's working. Testing. Testing. Okay. Yeah, that was a little bit more clear. All right. Hello, class. This is the midterm review. I'm using this worksheet that was posted on Google Classroom as my review sections. I'm just going to pick random questions from the pages from the textbook. I'll try to keep track of what the pages are, and I'll keep track of what problems we're doing. I'll do one of or two of each. The beginning is going to be quick, so that'll be done quickly for you guys. For my students in the 5th period class, I'll tell you when we stop on the things you learned. We're going to stop at chapter 5. For my 6th period class, it'll go down to chapter 6. So I'm just going to start off by doing a couple of problems from the textbook. So let's do page 5 or 6. That's section 1.1. So we'll see. All right. So with that in mind, let's go and start off. So section 1.1 was simply evaluate expressions. So that's like plugging in exponents. So like for example, it's very simple, but let's say number 3 from this one on page 5-6, it is 15x when x equals 4. So all you have to do is simply plug in 4 for x. So 15 times 4 equals 60. That was pretty easy. They also do exponents in this one. So like number 29, it's 11 to the 3rd power. So you got to remember with exponents, it's the same thing as saying 11 times 11 times 11. 11 times 11 is 121. And 121 times 11. Oh, well. Times 11, so which is going to be the 1331. So anything to the exponent is you just times it by itself. Again, you probably have a calculator with the exponent button. Another thing is evaluate the expression. We already done that. So section 1.1 super basic. It's just simply plugging in what you know from the information and solving it. 1.2 is more to the PEMDAS stuff. So 1.2, and this is page 10 through 11. The PEMDAS stuff is simply using the order of operations. So I'm going to do one without let's see. Let's do number 8. So number 8 is going to be 1 plus 5 squared divided by 50. 1 plus 5 squared divided by 50. So something like that, it's very simple. All you have to do is change to change 5 squared first, because PEMDAS, remember, is PEMDAS. Exponents is the second step. So since we have here, we're going to do PEMDAS 1 plus 5 squared is 5 times 5 or 25 divided by 50. Then we're going to do 25 divided by 50. That's going to be 1 plus 25 divided by 50 is the same as 1 over 2 or 0.5. I don't care decimal or fraction. 1 plus a half is going to be 1 and a half. Okay? Your multiple choice question, if you had a question like this, either is going to look like 1 and a half or 1.5. So make sure you know both of them. It's either 1 and a half or 1.5. What else is in section 1.2? Evaluate expression with a little bit harder, so let's do a tough one. Number 27 on page 11. So number 27, that is going to be 3 parenthesis m squared minus 2 when m equals 1.5. So they made it pretty tough. So m equals 1.5. So all I do is take my m and replace it with the m here. 3 parenthesis 1.5 squared minus 2. 1.5 squared should be 3 times 2.25 minus 2. So then, because I did the exponent first, then I do what's inside the parentheses. Even though this is a multiplication, I do what's inside the parentheses first. So 3 times 2.25 minus 2 is going to be 0.25. And then 3 times 0.25 is going to be 0.75. Don't worry about the fractions or the decimal. This is basic fractions, basic decimals. You should be prepared to handle a little bit of decimal like that. Let's go to 1.3. So this is 1.3. Let's see, and we have for us on page 18 and 19. Oh, changing verbal phrases to expressions. So this is a pretty important skill. Make sure you're able to do this. Helpful for word problems, helpful for these particular problems. So let me just do a difficult one, like number, let's do 9 and then number 10. So number 9, it says the quotient of twice a number t and 12. So the quotient, so you got to remember quotient equals division. So the quotient between twice a number t, so twice a number t, so that's 2 times t, and I put a little tail there so you know it's a t, and 12. So because it's twice the number t, then you say and, so that means now I'm doing the second part, so that's divided by 12, okay? Another way I could write this is 2t above 12. That's another way to write this. Make sure you can recognize both. Number 10 is going to be 3 less than a square of the number p. Okay, so 3 less than the number square p. If you're ever in doubt for these situations, what you should do is read it out like if there's actual numbers. So it says 3 less than the square. What is the square? The square of the number p. Number p. So even though it's 3 less than the square of the number p, that's the same thing as saying, let's change p to a number. So let's say 5, right? So 3 less than the square of the number 5. Well, that would imply I need to figure out what 5 squared is first. So instead of 5 squared, I'm going to put p squared. And then after that, I need 3 less than whatever that number is. So 5 squared is 25. So 3 less than 25, I would know that'd be 21 or 22. So p squared less than 3, so less than 3, that's going to be p squared minus 3. Okay? So those are expressions. We also have equations. So question number, let's do, is that an expression also? Let's do number 17 on page, so on the same page, on page 18. So number 17, we're going to do, each person shares a if p people share 16 slices to pizza equally. So I want to take as much pizza and then divide it into 16 pieces. So I'm trying to figure out, how do I share 16 pieces equally? Well, it's going to be p divided by 16. So p divided by 16, because I'm trying to break up all the pizza into 16 clean pieces. So p divided by 16. Okay, that's done with 1.3. Let's go to, I believe, 1.4, which is page 24 and 25. And that's going to be, let's look at the first number there. So for number 24 and 25, this is now writing an equation. So now you're going to have it actually equal something. So like number 4, you have something that says the difference of a number z and 11. So the difference of a number z and 11, difference means subtraction. So the difference between z and 11 is equal to 35. So we're going to put an equal sign, 35. Pretty simple there. Let's go and do the next one. Let's go to the product. Let's do number 7. It's number 4. Let's do number 7. The product of 9 and the quantity 5 more than the number t is less than 6. So there's a lot of going on there. So the product of 9. So we know product and 9, it has to do with multiplication. So let's write 9. So 9 and the quantity of 5 more than the number t. So quantity just means some amount. 5 more than the number t. So 5 more than the number t is the same thing as saying t plus 5, because I'm having 5 more than whatever t is. We're going to put parentheses there, because we know that has to happen first before we multiply, is less than 6. So is less than 6, so that's this. So 6 is here, right? So this over here, the left side, is less than 6. So whatever this number is going to make it smaller than 6. So the crocodile always goes and tries to eat the biggest one. So this is less than 6. So it has to go 9 times, and I'll draw this a little closer so it shows as a times. 9 times t plus 5 is less than 6. The product of 9 and some quantity, which is t plus 5, is less than 6. We're going to keep going. Let's do number 10. The product of 8 and a number k is greater than 4 and no more than 16. Now that's a tough one. So first off, let's just do the first part of the sentence. The product of 8 and a number k. So the product again means multiplication. And that was number 10. So the product of 8 and k. So it's 8 times k. Remember, with variables, you don't have to actually draw a symbol in between. So the product of 8 and k, let's move it here. Number 10. The product of 8 and k is greater than 4. So this thing right here, 8 and k, is bigger than 4. So this thing is going to be bigger than 4. So 4 is less than 8 times k. And is no more than 16. So no more means it could be equal to, because it could be 16, but it's no more than 16. So this is going to be 4 is less than 8k, which is less than or equal to 16. It cannot get bigger than 16, so it has to be smaller than 16 or equal to 16. And this over here, 4 less than 8k. Okay, so that's 11. Number, let's do one more from here. I'm just looking at my paper. Let's see. Let's go to 17 to 27. Let's see what's there. Check whether the solution. Oh, so this is a classic. So check the solution. So let's do a number. I'll choose a random one, 16. Let's see what 16 is. So, no, 16 is not in the section. Let's do another random one. Let's say 20. So 20 is k divided by 5 plus 9 is equal to 11. So we want to check if 10 is a solution for this. So we want to plug 10 in and see if it works. So I'm going to do 10 divided by 5. K become 10, so I'll put parentheses around it, plus 9 equals 11. 10 divided by 5 is 2, plus 9 equals 11. 2 plus 9 equals 11. 11 equals 11. Because that's true, we're going to say yes is a solution. Okay? This is also just helpful for you if you're in a bind and during the multiple choice section and you're like, man, I have no clue how to do this. You could take your multiple choice answers and plug it into the equation sometimes to see if maybe one of those answers give it to you. That's a test taking technique that you guys should know. So if you have a multiple choice situation, go and plug it back in. Then you would could find the answer, especially if sometimes you're just stuck or you're panicking. Plugging it back in can give you that answer. I'm going to do one more. Let's do 25. So that's 2 plus 3x is less than 8. So 2 plus 3x is less than or equal to 8. I apologize. So we're going to check if 2 is a solution. So notice this is an inequality, so it's not like normal. So 2, we're going to plug it back in. So 2 plus 3 times 2 is less than or equal to 8. 2 times 3 is 6. 2 plus 6 is less than or equal to 8. 6 plus 2 is 8. 8 is less than or equal to 8. 8 equals 8. Or is 8 less than or equal to 8? Well, they're actually equal to, and that's okay because the original problem had less than or equal to. So this is also a yes. Okay. We're going to go on to the next one. Students 1.5, page 31 and 32. Page 31 to 32, section 1.5. Okay. 31 and 32. Describe and correct let's check what the questions they asked us to do. So let's do 3, 5, 8, 12. Let's see. So this one is a problem solving one where we're trying to figure out. Let's check this. Yeah, using problem solving. So we're trying to problem solve the situation. Okay, so let's do number 8. No, let's do number. Let's see what's a good one here. Well, let's do number 9. So a store buys a baseball cap for $5 and sells it for $20. So basically this section is not too important in terms of like knowing the formulas or anything. I won't test you on those formulas. What I really just care about is this is supposed to be a section to help you analyze and read word problems. So for example, For number 9, it says that a store buys a baseball cap for $5 and sell it for 20. What's the profit? So the problem solving plan is, well, let's figure out what we need to, what is important. So we know that to buy a baseball cap, he has to spend $5. So every time he buys a baseball cap, he loses $5. Then he sells it for 20. So when he sells the thing, he gets $20. So the profit between that is going to be very clearly $15 because 20 negative 5 plus 20 is $15. And it makes sense. One hat costs him $5, but he makes 20 on it. So 20 minus 5 is 15. This section is not too important, so I'm going to skip by it. What's really important about it is just that it helps you analyze word problems. So I think the next section should be 1.6. 1.6. And that's going to be on pages 1, 2, 3, 4, 5, 44 and 45. Is it 1.6? Or is it 2? No? Wait, what? I guess we're on 1.7. We skip a section. Okay, that's fine. So we do 1.7. So page 44 to 45. All these things, the functions. Yeah, so these are cool. So you got to remember the one and only rule about functions. It's that when you plug in a function, it has one rule, and this is it. So please write this down. Every input has one unique output. So every input has a unique output. So for like number 3 and number 5, and hopefully one that fails and one that passes. And then I'm going to do number 7 afterwards. So number 3 is a table. 0, 1, 2, 3 is your inputs. And your outputs are 5, 7, 15, and 44. So when you put in a 0, you get back out a 5. When you put in a 1, you get back a 7. What's really important is not the numbers that I get out, is that none of these are going to be doubled up by the other one. So for example, 0 only gets 5. 1 only gets 7, and 2 gets 15, and 3 gets 44. It's not like 3 could also be 15. Who cares that we only get one unique situation. Let me go to 7, because that's the one I really care about. I want to show you a failure case. So this is 1/2. Excuse me. 2/3 and 3/4. So 2/3 and 3/4. And then we have another side, which is 0, 1, 3, 5. 0, 1, 3, 5. So 1/2 goes to 0, 2/3 goes to 1, 3/4 goes to both 3 and 5. So what's very interesting about that is that 3/4, the problem with 3/4 is that it has two outputs. This one input can't be two outputs. Think of it like a functioning like machine, right? If you put in a bag of popcorn in the microwave and you get out, like a fillet of fish, like your machine is broken. It should only give you one thing, which is popcorn. It's not functioning correctly. So this 3/4 is not functioning correctly because sometimes it gives you a 3, sometimes it gives you 5, and that's not okay. This is page 45. Let me look through what's 11 and 15. And what's 15? Yeah, there's 15. Oh, okay. So 15 is good. Identify the range and making a table. So number 15, the question is, I'm looking at the wrong section. Okay, number 15 is perfectly fine. Y equals x plus 3.5, and your domain is 3, 5, 7, 8, 12. 3, 5, 7, 8, 12. Okay? So what is domain? Remember domains are your inputs. So domain equals inputs. And in terms of x, y, inputs are always x. So I'm going to make a table, so x, y, and this one I'm going to do sideways, just to show that it doesn't matter which way, if it's vertical or sideways. So I put 3, 5, 7, 8, I'll make it a little longer for 12. So what I'm going to do here is plug in 3 into this formula. So 3 plus 3.5, and then that is going to go here, so that's going to be 6.5. I'm going to plug in 5 for x. 5 plus 3.5, which goes over here, is going to be 8.5. So what are you going to do? You're going to do the same thing. 7 now. 7 plus 3.5. Bring it up into this. 10.5. And then 8. 8 plus 3.5 is going to be 11.5. And you know how to finish it off. Give you a second. We're going to plug in 12 into x. We're going to do 3.5. So 12 plus 3.5 is going to be 15.5. And then this is your table. So you're happy at this point. You're done. You finished putting in the domain. Okay. So that is 15. That is section 1.7 apparently. Let me just check again. Yep, 1.7. We're going to now page 52 and 53. Oh boy, this thing's not working right now. So we're going to go to page 52 and 53, which should be... Oh, graphing. Okay, perfect. So 52 and 53, and let's see, I got some graph paper here. Okay, good. Okay, so I'll keep this on the side or something. So it's graphing. This one is not even graphing lines. All we're doing is graphing points given a domain and range. So I'm going to do number 5. So number 5, let me just put it in camera. The equation is y equals 2x plus 2, and your domain is 0, 2, 5, 7, and 10. Okay? I don't know what that mark is over here, but... So domain is this. Remember, domains are x's. So I'm going to make a vertical table this time. It really doesn't matter. And I'll use the blue lines as markings. So my domain are all my x's. So 0, 2, 5, 7, 10. And then I'm going to find out my range. So I'm plugging 0 for here. So 0 times 2 times 0 plus 2. Well, that's going to give me 0, and 0 plus 2 is 2. Let's plug in 2 here. 2 times 2 plus 2, so that's 4, plus 2 is 6. 2 times 5 plus 2. 2 times 7 plus 2. And then 2 times 10 plus 2. 10 plus 2 is 12. 2 times 7 is 14. 14 plus 2 is 16. 2 times 10 is 20. 20 plus 2 is 22. So that's what we got. And does it say to graph it? Oh, we would to graph it. So how would you graph this one? My table on the right won't fit it. But basically, you just have to put the coordinate point. So the coordinate point is 0, 2. It would be 0 to the right and up 2. So that would have been your first point. Next one's 2 comma 6. So 2 is your x, so I would have went 2 right, 1, 2, and went up 6. 1, 2, 3, 4, 5, 6. And here's my point over here. And would have kept going, you know it should be a straight line from the later chapters. So those are your points, and you would just put the points and fill up the graph. Okay, so that's that. We're going to finally go to chapter 2, page 76, 76 to 77. And this is solving linear equations, okay? The first thing we need to do is take care of square roots. Just remind us what a square root is, and I think it's 2.1. Is this 2.1? Yeah, 2.1. So let's do number, on page 76, let's do number 8. So 8, that's a plus or minus the square root of 121. So you need to recognize the square root of 121. That's definitely something you should notice. Now the square root of 121 is going to be, well, let's see. I know 10 times 10 is 100, so let's try one more. 11 times 11 is going to be 121, if you're not sure. Equals 121. So then your square root of 121 is going to become a smaller number, which is plus or minus 11. All you're doing is having the square root. That's the opposite of squaring something. So like 11 squared equals 121. So the square root of 121 equals 11. Okay? So they're like they're reversed to each other. Okay? Number 10, which is negative square root of 256. Negative square root of 256. I know, but you can always check in your calculator. You could ask that in class if you don't know how to do that. Is going to be negative, and then the square root of 256 happens to be 16. So negative 216. So that's 2.1, that's 8, that's 10. Let's go and do more. So that's 8, 10. Let's see what else we got here. 35 to 41. What is that? Oh, 35 and 241 is just plugging it in. So let's try number 36. What is 36? So what is 4 times square root of x when x equals 49? I'm a little ahead of myself. You just plug it back in. So 4 times the square root of 49. Now, very important to understand this in terms of order of operations. A square root is in the same churn order as a square or an exponent. So the square root of 49 is going to be 7. You got to do that first. And then 7 times 4 is going to be 1428. So the square root of 24 is 4 times 7, which is 28. Okay. So TP 2.1 is square roots. Now let's get to 2.2, which is on page, press this out, 87 and 88. One-step equations. I'm going to actually go to, well, let's just do a quick one-step equation. So one-step equation, two-step equations, multi-step, compound. These are all going to be basic things you definitely need to know. If you somehow don't know it and you're still here, we're going to need extra studying, okay? If for some reason you don't know how to do one-step equations, we're going to have to help you a lot. Okay, so this is number 11. I'm going to pick this one because there's a negative k, and we're going to deal with that. So, even though there's a one-step equation, we want to figure out what k is. But k, oh, I'm sorry, I misread the question. It's equal, and this is minus 3. No, I'm dumb. So then that means that you just go do plus 3 plus 3. You use the opposite operation to cross this out. That's 17 equals k. So you just use the opposite operation. So 2.2 is one step. 2.3 is two step. So I'm going to skip over to 2.4, which is multi-step. And that's going to help us practice all the ones beforehand. So that seems to be page 100. Okay. So let's do numbers 3, 6. Now where's one you don't combine like terms? Let's just do 3 and 6. Okay, so number 3 is p plus 2p minus 3 equals 6. And then I'm just going to write number 6 here. 5a plus 3 minus 3a equals negative 7. 5a plus 3 minus 3a equals negative 7. So for here, you got to combine like terms as much as possible. P plus 2p is going to be 3p minus 3 equals 6. Now, since this is a minus 3, we got to do the opposite of minus, which is plus. So plus 3, plus 3. In terms of choosing which one goes first, either the 3 in front of the p or the 3 that's being subtracted, you kind of want to go reverse PEMDAS when you're trying to get p by itself. So after you combine like terms, you want to get p by itself. The first thing you want to do is take rid of anyone who's farthest away. In this case, it's 3 over here. So you're going to add 3 and add 3. So that's 3p equals 9. This is a very 3 heavy question. We're going to divide by 3 now, because what's times p? The opposite of times p is divided by p. And that's going to be p equals 3. No joke, it's a 3 heavy question. So now let's do here. 5a minus 3a. So it matters what number is in, or what symbol is in front of the symbol. It don't matter that 3 here is a plus sign. What I care about is what's in front of 3a, which is a minus sign. So 5 minus 3 is 2a plus 3 equals negative 7. It's okay if you wrote 3 plus 2a, that's the same thing. Minus 3, 2a equals negative 10. Then I'm going to divide by 2 on both sides. A equals negative 5. Let's just do one more. I'm going to look for a harder one. Let's see. Let's check. Oh, we didn't do a distributive property one, so that's perfect. So let's do number 14, or number 13, I'm sorry, which is 14 plus 2 times 4g minus 3 equals 40. So 14 plus 2 parentheses 4g minus 3 equals 40. Okay. So then we're going to have to solve this. So 14 plus 4g minus 3 equals 40. So we are going to subtract 14 on both sides. So we have 2 times 4g minus 3. Actually, before we do that, usually we want to distribute first and simplify the left side as much as possible. So my fault on that. So I'm going to do is take this 2 and multiply everything that's on the inside. Don't forget this guy. He's important too. So 14, 2 times 4 is 8g. And then 2 times negative 3 is negative 6 equals 40. Then we're going to combine like terms. Now, when you combine like terms on the same side of the equal sign, you do not need to do the opposite operation. They're already in the normal land. They don't do the normal thing. So 14 minus 6. So 14 minus 6 is going to be, and I'll put it over here, is going to be 8. So 8 plus 8g equals 40. Now here's 8, so I'm going to now just do like a 2-step problem. Minus 8 8g equals 32. Then I'm going to divide by 8, divided by 8, cross this out, g equals 4. Now, before I was early doing it by subtracting 14 first. You could technically do it that way, but I'm going to keep consistent to the way I always said, which is distribute first, then solve. So that was number 13. I'm going to do another one. This is on page, what is this, on page 101 in your textbook. And this, let's do number 20, number 16. So number 16. 27 equals 3c minus 3, parenthesis, 6 minus 2c. 6 minus 2c, close parenthesis. All right. So when you distribute this one's a little interesting, because when you distribute this one, you have to not just distribute the number, you're going to have to also distribute the negative in front of it. So when I distribute this whole guy is going. So I'm going to bring one here, and I'm going to bring one here. So I have 27 equals 3c. That stuff did not change. Negative 3 times 6 is going to be negative 18. You could say this is a minus 3, but remember, when we're talking about multiplication, we don't care if it's a minus 3. We call it a negative 3. So negative 3 times negative 2 is going to end up being a positive 6c. Now we're going to combine like terms, which is 3c and 6c. So we have 27 equals 9c minus 18. We're going to do plus 18 on both sides. So that is going to be, carry the 5, 1. That's going to be 45 equals 9c, divided by 9, c equals 45 divided by 9, which is 5. So c equals 5. Remember the strategy on the multiple choice. You could take 5 and plug it back into the original to check your answer. I just want to do that once to show you that it's a very useful skill. 27 equals 3 times 5 minus 3, parenthesis, 6 minus 2 times 5. 27 equals 3 times 5 is going to be 15. Minus 3 multiplied by 6 minus 10 is going to be negative 4. This is going to become 10, so please know that. Negative 3 times negative 4 is going to be 15 plus 12 equals 27. 27 equals 27. So that is a way to help you strategize and use it on the multiple choice. Just take one of the options and plug it back in to see if it works. If you're ever in doubt, it's usually faster to actually solve it out. But sometimes when you're panicking or you forget a question, you can't ask a question, just plug it back in and try. So that was page 101. I think that was section 1 point or 2 point something, 2.4. So we're going to go to the next section, which is 2.5, which should be multi-step, if I'm correct. Oh no, variables on both sides, which is better. Let's do I want to do a difficult one. So let's do number 11. So this is 2.5. And this is on page 107. We're going to do number, number 11. Yeah. Okay, number 11. So, with that in mind, let me write it down. 3 times d plus 12, parenthesis, equals 8 minus 4d. Okay? So these are parentheses. So we know when we see the parentheses, hopefully this refocuses. So when we see the parentheses, we're going to distribute. So 3 times d is 3d, and 3 times 12 is 36, equals 8 minus 4d. Now, my strategy to always do is to move the smallest variable first. So which one is smaller, 3 or negative 4? Well, the smallest thing is actually negative 4. Negative 4 is like 4 in the basement, while 3 is 3 above ground. So I'm going to do plus 4 on this side, so plus 4d. And I'm going to do plus 4 on this side. The reason I put it here and not on the side is because when I can combine actual like terms, I want to add it directly to something. So 3d plus 4d, this gets crossed out, is going to be 7d plus 36 equals 8. Then I'm going to subtract 36 on both sides. And that's going to be 7d equals 8 minus 36, which should be negative 28. And then I'm going to divide it by 7 on both sides. Get rid of the 7. D equals negative 4. Seemed like a tough one, so I'm just going to do another one for example. Let's do number 13. They circled it, so it must be difficult. So number 13, the book circle, that's it. So that is 40 plus 14j. Let me use a lowercase j actually. Equals 2 times negative 4j minus 13. 2 times negative 4j minus 13. Okay. Camera keeps freezing. I apologize for that. Okay. So we're working over here. So I'm going to distribute my 2 every time. Now let's put more space. 40 plus 14j equals, this is going to be negative 8j, and 2 times negative 13 is negative 26. Again, I want to move the smallest one, so 14j and 8j, negative 8j. Negative 8 is smaller than 14, so I'm going to do plus 8j plus 8j. So now I have 40 plus that is plus 22j equals negative 26. So what else am I going to do other than subtract 40 on both sides? So 22j equals negative 66 divided by 22 divided by 22. J equals negative 3. Okay? So all you're doing is trying to get the variable to one side, then solve it out like a multi-step. Let's see. Okay, so let's keep going. Yep, there's just more of that stuff, so I want to keep going and make sure I finish before like 10 o'clock tonight. I'm not really going to go that long, but you never know. So let's go to page 117, which is ratios and proportions. Okay. So ratios and proportions is really important. So this is 2.6, and this is page 107. Again, if you don't know, I'm following this worksheet. This is attached to your Google Classroom. So for some of you, some reason the word got like strung out, so they use one in space. I have no clue why it does that. Just scroll all the way down on your computer. If you got the printout that I gave you earlier, it should just be normal. But this just basically says bring your calculators. So page 107, 117, not 107, I'm sorry. 117 is ratios and proportions. So this is really important. So first we're going to figure out how to solve a proportion. So I'm going to skip to number 13. And that is 5 over 8 equals t over 24. So 5 over 8 equals t over 24. So, even I'll use the calculator. What you do in this situation, when you see an equal sign between two fractions, is you're going to circle diagonally this way and circle diagonally this way. This is called the butterfly method. So what we're going to do is multiply diagonally. So 24 times 5. So 24 times 5 should be 120 equals, and now we're going to do 8 times t. Well, I know that. It's going to just be 8t. Now I know I have to divide it by 8 on both sides, divide by 8 on both sides. So I'm going to end up getting t equals 15. So t should equal 15. I'll do another one because it seemed like my camera froze at the moment. So let's do number, what does the book suggest to do? Let's do number 17. So number 17 is 16 over 48 equals n. 16 over 48 equals n over 36. So again, I am going to cross multiply. So I am going to do 16 times 36 here and 48 times n. 16 times 36 equals a big number, 576, equals 48n. Divided by 48, divided by 48. Notice that this pattern is always the same. You're basically going to multiply these two and then divide it by the one that wasn't, that was going to be connected to the variable. So 48 divided by here, 48 divided by here, 576 divided by 48 equals 12. So 12 equals n. So 12 equals n. Yeah, that's pretty much it. So when we get 12 equals n, put a little more space, we're done. Now, what's really important, especially for your fifth period, guys, is going to be one where we actually have a whole expression on the other side. So let me see. Do they have one? I'm going to do a quick one. Number 41. Number 41. It's on the next page, so not 1017, but 118. 41 is a tougher one. So let's look at it. Wow. 41 I don't like. Let's do number 40 instead, actually. 41 is just obnoxiously big. So let's do number 40. So that is 5 over 13 equals k minus 4 over 39. So why is this significant? Because when I do my cross multiplication, I'm just not multiplying to a variable like this one was, and I just get 8t. That's super easy. Well, first let's just do the straightforward thing. 39 times 5. Oh, that's times 4. Oopsies. 39 times 5 equals 195. Makes sense. Equals, now this is going to be 13 times k minus 4. So these are multiplying. I got to multiply with parentheses. I can't make that mistake, or I'm going to get the completely wrong answer. So I'm going to distribute 13 here and 13 here. 195 equals 13k minus 13 times negative 4. So 13 times 4 is 52. Now I'm going to do plus 52 on both sides. So that's 13k equals 724, 274. And then divided by 13, divided by 13. This is going to be k equals 19. So k equals 19. So remember, if you have a whole section, like here where it's k minus 4, you have to make sure to eliminate you have to multiply it to everything. So 13 goes here, and 13 goes here. So 13k minus 42. You cannot just you can't just multiply k or something like that. Okay, let's go to 2.7, cross products. which I already did one, but I'll do it again. Let's do number 13 because they suggest it. So this is page 123, 2.7, 2.7, page 123. Numbers, we're going to do let's do number 13 because that's what the book suggests us to do. So that is 11 over W. 11 over W equals 33 over W plus 24. So we're going to cross multiply. So that is going to be 11W plus 24 times 11 equals 264. Oh, I should actually, let me write it like this so I don't get too confusing. So 33 times W is 33W equals 11 times W plus 24. Is it 24? Yeah. Now I'm going to distribute the 11 to both of them. So 33W equals 11W plus 264. And I'm going to see. Now, here's the difference, right? Now it's a 33W, right? So I'm not going to subtract 264. I'm actually going to subtract 11W on both sides because I want all my W on one side. So 11 minus 11W crosses out. I have 22W equals 264 divided by 22 divided by 22. I believe this should be 12. I'm just going to check. 264 divided by 22. No, I multiplied. 12. So W equals 12. Let's do another one in the next section, the solving proportions. I assume these are going to be a little tougher, so let's do number 20, which is A over 9A minus 2. So A over 9A minus 2 equals 1 over 8. Okay, that's not too bad, actually. This one's pretty simple. So we're going to cross multiply. A times 8 is 8A equals 9A minus 2 times 1. Anything times 1 is going to be the same thing. So I'm just going to write 9A minus 2. I'm going to subtract 9A on both sides. So I got negative A equals negative 2. Divide by a negative 1. Why do I divide by negative 1? I don't like this negative here, so I have to get rid of it. So goodbye. And then here, negative 2 divided by negative 1. That's not going to change the value. It only changes the sign. So A equals 2. So 2 over, what's 2 times 9? That is 18. 18 minus 2 is 16. So does this match up? 2 over 16 is equal to 1 over 8. Yeah, that matches up. So that kind of checks our work right there. I think that should be done with chapter 2. Oh, no, I'm wrong. I'm completely wrong. Page 129. Got a bone to pick with us before we go on. Let's see. 129. What is that? Oh, rewrite equations. Okay. So this is a pretty important skill. I know a question exactly like these. So let's just do 1. So classic example is like number 11, where I'm trying to get y by itself. So 2x, actually, let's do a harder one, since I'm doing this video. Let's use number 12 instead. Does it even suggest to do number 12? Yeah, that's fine. So let's do number 12. So that is 5x plus 4y equals 10. And we've used this skill before to get y by itself and then graph it in the y equals mx plus b form. So I'm going to subtract 5x on both sides because I want to get y all by itself. So that's 4y equals 10 minus 5x. Then I'm going to divide by 4 on both sides. Now, when you divide by 4, Here, it's kind of like a distribution problem. Everyone gets a little bit of the 4. So y equals, and we don't care if there's a fraction, 10 over 4. I'm going to reduce that to 5 over 2. Minus 5 over 4, can't reduce that, so I'm just going to leave it as 5 over 4. So 5 over 4, x. Don't matter if you draw a slight lines here. Actually, it would be drawn vertically if it was a multiple choice question, so I should continue to draw it like that. 5 over 4x. It could also be written, don't worry if it's written like this, or you wrote it like this, negative 5 over 4x plus 5 over 2. That's how it also could be written. Okay, so that's 2.8, I imagine it was. It has to be. That only makes sense. So now I think we're free of chapter 2. Now we're back to something you should have on your printed out test and something that should at least familiar. 149. So now 149 is to name those coordinate points. Oh gosh. So this should be free points for most of you guys. Remember that this is page 149. Numbers, I think it asks to do 3 to 20, 23 to 27. These are some key things to remember about graphing, and this is important. Your coordinate point is always x comma y. Always, always, always x comma y. X's go left to right. Y's go up to down. Now, I just want to mention this now. It's not important to this section, but it's going to be important in a couple sections. Slope is always rise over run. You always rise above the running, okay? You rise above the running. So because of that, that means rise is usually the y1 minus y2 over x1 minus x2. So the y's go on top here. Even though y's go second here, y's go on top here. Sometimes I notice you guys get confused in that, but it shouldn't be a big deal. So for numbers 3 to 12, it's just pointing out where the coordinate point is, and number 14 to 20 is actually plotting the point. So just to do a quick one, so I'm going to do this here. Let's do numbers, let's do 16 to 19. So 16 to 19, number 16 is negative 3 comma 0. So negative 3 comma 0 is number 16. So that means I'm going to go negative 3 is my first number, so I'm going to go 1, 2, 3 to the left, and then 0 up. So 1, 2, 3 to the left and 0 up. I'm going to put a point right here. So this is number 16. I think the letters are on the question. Number 17 is 0 comma 0. So 0 comma 0 has a special name as our origin. So 0 up and down, and then 0 left and right, 0, 0. Right in the middle. I think they would put S in here. Last one, negative 3 times negative 3 comma negative 4. So that's 0 comma 0. And number 18 is negative 3 comma negative 4. So negative 3 to negative 4, I start at the origin, and negative 3 tells me I'm going to go 3 paces back, 1, 2, 3, and I'm going to go 4 paces down, 1, 2, 3, 4. Negative 4. This is RS, I imagine this is T. And number 19, letter U. Number 19 is 0 comma 6. So this is if you notice, this might look like a y-intercept. So 0 means 0 left or 0 right. And then comma 6, that means I'm going to go 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6 up. So there's my point, and that's RSTU. So that's the letter U. So graphing points, you definitely should know that. I just wanted to go over that quickly. So we established that. So let's get to the next section now, which is 157, I'm sorry, 157. So that should be 3.2. We are, what are we doing here? Graph linear equations. Perfect, perfect. So, this is page 157. So we're going to graph a linear equation. So there's two ways to graph, guys. One is to use y equals mx plus b. Another one is to make a table. So I'm going to do both for the same question to show you that you're going to get the same result. So I'm looking right now. It says to do 357. What is this? 357. Oh, well, let's first do that. 357 is just plugging in to see if your expression is correct. So let's do number 7. When you put in an order pair, so this one is negative 7x minus 4y equals 1, given that your coordinate point is negative 3 comma negative 5. Okay? So you have 11, oh, this is 4, I'm sorry, y, negative 7x minus 4y equals 1, semicolon 3, 5. Remember, your first number is always x, your second number is always y. Let's plug it in to see if it's true. I can kind of tell that it's not going to be, but we'll plug it in to figure it out. So negative 7 is going to be times by negative 3. So negative 7 times negative 3 minus 4 times negative 5 equals 1. Negative 7 times negative 3 is positive 27. Negative 4 times negative 3 is positive 20 equals 1. 27 plus 20 is 47. And let's look clearly. Is 47 the same thing as 1? No. So the answer is no. It's not true. Okay. So it doesn't say graph. Let's actually graph. So let's do numbers. Let's do number 11. So number 11, y equals 2, x minus 2. So I'm going to show you how to graph it with both methods, okay? First, I want to do the table one, because the table one is kind of like a safe bet. With the table, you can make a table with x and y, and you put 3 to 5 points. So I usually do negative 1, 0, 1. You could put 0, 1, 2. You could put 3, 4, 5 if you want. Know that these are the smallest numbers, so that's why I typically put it. And then I'm going to actually draw in the middle of this table, and I used to do this before, so let me continue my methods, is I'm going to write the equation itself. So y equals x minus 2. So here in the middle, I'm going to plug in all my x's. So y is going to equal negative 1 minus negative 2. Well, negative 1 minus 2 is negative 3. We're happy with that. 0 minus 2, that's negative 2. Okay. And 1 comma 1 minus 2 is going to be negative 1. So those are our points. So your 3 points would be negative 1 comma negative 3, 0 comma negative 2, and 1 comma negative 1. Now let's say if I use y equals mx plus b on that, okay? So the equation was y equals x minus 2. I point out my b is negative 2. I point out my m is 1 over 1 because there's no number in front, so I'm going to call it 1, and then I make it a fraction. So let's see if this stays true. So I'm going to go down 2. And remember, if your m is 1 over 1, that's the same thing as saying you're going up 1 and right 1, which is the same as going down and left. Okay. So up 1, right 1. And let's just do down 1, left 1. Well, let's look at this point. This point right here is negative 1, comma, and we go 3 down, negative 3. Well, that should look familiar. This one in the middle, our y-intercept, is 0, comma, negative 2. Well, look at that. That looks familiar. And this is 1, comma, negative 1. So I hope you understand that graphing with a table and graphing with y equals mx plus b is the same thing. It's a preference, honestly, whatever you like to do. So we've done a lot of graphing. I do want to go light on this. I want to go over more obscure stuff. So I'm going to continue on to the next section, which is page 167. I guess I wrote the question twice for some reason. 167. Okay, I apologize. 167. So let's go to intercept form. So we all know y equals mx plus b, but what's useful about intercept form is it's very easy to find its intercepts. And so intercept form is typically written, actually, I'll just show you how to get the intercepts. So which ones do I suggest to do? 5 to 27 odd? So let's do number 9. 9 is perfect, okay? So number 9, 2x minus 8y, and this is on page 167. 2x minus 8y equals 24. Now, this question asks you to find the intercepts. So we need to find the intercepts. And let me focus the camera so it doesn't look so foggy. There you go. So there's two things we need to do. On this table of x and y, we need to figure out when x equals 0 and when y equals 0. So hopefully this is making you familiar. So first let's plug in when x equals 0. 2 times 0 minus 8y equals 24. Negative 8y equals 24 divided by negative 8 divided by negative 8. Y equals negative 3. So y intercept is 0 comma negative 3. Where does it hit the y-axis? At 0 comma negative 3. Now we want the x-axis. So where does it hit the x-axis? So that's when y equals 0. So I'm going to plug it in here. 2x minus 8 times 0 equals 24. This is going to get crossed out. So 2x equals 24. Divide by 2, divide by 2. X equals 12. So we're going to take this 12 and plug it right back here. So you have your 2 points, 0 comma negative 3 and 12 comma 0. If I didn't got a don't worry about it, GPA nerd, whoever you are. You could always just rewind it and watch the video again. And we have 3 days of a review. So any questions you have on the video that you can't ask on the live stream, you just literally go back and then ask me in class, okay? Because we're literally going to have 3 days dedicated to review. So x, y, 0 comma negative 3, 12 comma 0. So no problem. So what we're going to do here is going to graph these. So typically you want to graph these. On the multiple choice, you probably don't have to graph these. You might just have to point them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to squish this real close. Negative 3, 1, 2, 3. But you could graph it like this and you get 2 points and just connect the dots. Sometimes it's easier like that. So that's what checking for intercepts is. So if I ask you for intercepts, your answer should be 0 comma negative 3 and 12 comma 0. It might be also written as y-intercept equals negative 3 and x-intercept equals 12. So if we're talking about a multiple choice question, it's either going to look like the top line or these two bottom lines. So keep an eye out for both and understand that they're the same thing. Okay? So that's page 167. I just want to flip because I put it separately. Did I put it separately for a reason? No, it doesn't really matter. So let's go to the next one. 177. If I remember this, should be standard form. Find slope and rate of change. Okay, so finding slope. All right, so you could find slope in multiple ways. The typical way you want to work with it is either by, when I give you 2 points. So they circled number 11, so let's do number 11. This is on page, this is not 167, this is on page 177. Number 11. So they circled it, so I'm just going to do it. They think it's a good idea. So we're going to do 1 comma 3 and 3 comma 2. 3 comma negative 2, my fault. Now what we got here is really important is that we need to know this equation. You will not be getting this equation on the test. So make sure you remember it. y1 minus y2 over x1 minus x2. So I'm going to redraw this so they're on top of each other. So 1 comma 3 and 3 comma negative 2. And now I'm going to identify it. This is the x's and this is the y. That's always true. I'm going to call this one group 1 and I'm going to call this one group 2. So when I plug in this equation, I need to make sure I pick in the correct y and the correct x's, okay? So if I say y of group 1, that's y with the last name 1, that happens to be 3. So I'm going to plug in 3 here, minus y of 2, so that's y of group 2, that's negative 3, or negative 2, my fault. So that goes there. Next one is x and to the 1, so x to the 1, that's a 1, minus, we're going to do x to the second, so x to the second happens to also be 3. So then we're going to keep going. 3 minus negative 2, well, 3 minus negative 2 is the same as 3 plus 2, so that's going to be 5. And 1 minus 3, that's going to be, you're on the first floor and you go down 3 floors. You're in 2 floors in the basement, so negative 2. So your answer, and you can't simplify this, so your answer is 5 over negative 2. Now the answer might be written like this, negative 5 over 2, with the negative in front, or even negative 5 over 2. Know that these are all the same thing. So if there's a negative in front, on top, or on bottom, that is all the same thing. Okay, so that's finding slope. We do a lot of that in graphing. So I think the next, I don't know which the section is next. So page 185, number 3 to 38. So that's a lot of questions. I know, I'm sorry. Identify the y-intercept and identify the slope. Okay, so I'm going to do the harder one straight ahead, which requires us to rewrite it, then identify. So I'm going to do number, again, they circle 11, but I want to do a harder one. So we're going to do number, let's do number 16, okay? So this is going to be number 16. So number 16 is negative x minus 10y equals 20. Now what's really important here is that you have to get y by itself, and we did this in the previous section. So I'm not going to go too much in detail. First, let's move all the variables away from y. So that's plus x. So you got negative 10y equals x plus 20. Do not worry if you write it as 20 minus x. Then divided by negative 10. Now when you divide by something here, you have to divide everything here. So divide by negative 10, divided by negative 10. Y equals 1 over negative 10x plus 20 divided by 10 is negative 2. So I can rewrite it as minus 2. Okay, but we're not done because it asks us to identify both the slope and the y-intercept. So since it's always y equals mx plus b, my m is the number in front of the x, which is negative 1/10, and my b, which is the number in front of by itself, which is negative 2. So my actual final answer is here. Slope equals 1/10, a negative 1/10, and b equals negative 2. I could have rewritten it as like with the full word. So I could have said slope is negative 1/10 and y-intercept. Be prepared for either version on the multiple choice. Okay, because slope is negative 1/10 is the same thing as saying m is negative 1/10. Okay. Okay, that's identifying slope-intercept form. Let's go to next chapter, I believe, on page 226. Let's see, 226. Chapter 4.1. Oh, now we're graphing these slopes. Okay. So we're now going to graph. I'm going to do a quick one because it's not too pertinent. We have a lot of practice in graphing and other things. So let me pick one that's useful. Let me pick a more difficult one, not one that just gives you the slope and intercept. Perfect. So let's do number 25. We're going to do 25 and then we're going to do 30. So number 25. So number 25. What is it asking us to do? Write the equation. Perfect. So 2 comma -7. And the other one is 0 comma -5, I believe. -5. Okay. All right. So we need to find y equals mx plus b. And we actually have a formula to solve for m, which is y1 minus y2 over x1 minus x2. So with that in mind, we're going to flip, we're going to plug in correctly. So x, y, group 1, group 2. Y group 1 is -7, so -7 minus y of group 2 is -5, so minus -5, over x of group 1 is 2, minus x of group 2 is 0. Bottom is much easier. So -7 minus -5. That's the same thing as saying -7 plus 5. -7 plus 5 is -2. 2 minus 0 is +2. And I can reduce that to -1 overall. So that my slope, or my m, equals -1. That's really useful. So so now I know that m equals -1. Now I'm going to use that to help me find b. So I'm going to use this equation and plug in something. So I'm going to pick the easiest point. Because this involves a 0, this is a pretty easy point. So I'm going to change I'll just write it this. Y equals mx plus b. So y is going to become -5 equals 0, or equals our m, which is -1, times 0 plus b. 0 times -1 is 0. So -5 equals b. That was real easy. Notice if you have x equals 0, and we talked about it before, if x equals 0, you already have your y-intercept. So I could have, I could have just skipped and said, well, I know b is -5, so I'm going to skip right to -5. So then I just got to put the equation all together. You got the ingredients, now you got to put it all together. Y equals -1x minus 5. On a multiple choice, it probably is going to look like y equals -x minus 5, because you don't have to draw the 1. So on a multiple choice, be prepared to see that. And then I want to do number 30. This is for the third period class, when you have f of x. So if f of 0 equals 2, and f of 2 equals 4. Now, this might not be memorable, but this is basically your x and this is your y. So I could rewrite this as 0, 2, and I could write this as 2, 4. Now I'm going to call this x, y, group 1, group 2, and I'm going to do this quickly now. 2 minus 4 over 0 minus 2, -2 over -1, which is going to be +2, which equals m. So now we have m equals 2. We want to find a y-intercept. From what I pointed out back there, I'm going to just skip to the chase. If it's a 0 in the x, I know 2 is going to be the y-intercept. If you don't believe me, you can plug in 2, 4, and you'll see it's still the same. So I know my equation's y equals 2x plus 2. The thing is, I'm not going to use y in the multiple choice because this is a function notation. I'm going to write f of x equals 2x plus 2. So you got to look for this answer, okay? Do not click this answer. You're going to pick this answer. That's page 226. It looks like I'm more than halfway done, which I'm happy about. So 236, no, should be more, recent territory. 236 is, what are we doing here? What are we doing here? Using a linear equation and slope intercept for. I've already done this before and I do it, and I'm not gonna do it again. So that's just more practice of what I just did on that one. So let's do 308. And this should be, what is this? And this should be solving inequalities. Okay, so we're going right to chapter 5, I guess. So that's the basics of graphing. I'm not going to spend too much time on that. So that's done. So 308, page 308. We're on chapter, in terms of thing, we're on chapter 5. Solving inequalities. Now, there's one golden rule with solving inequalities. So if you don't have it, get it down right now. We've gone over it both of the times. When you multiply or divide by a negative, switch the inequality. Once again, when you multiply or divide by a negative, you're going to switch that inequality. So I'm going to pick one that purposely show that. So let's do number 5. Okay, so number 5, negative 6y is divided by negative 36, or I'm sorry, is less than 36. I'm going to divide it by negative 6. Just like you're solving an equation, you do the same thing. So y, and this is going to be a positive 6, because 36 divided by 6 is positive 6. But this symbol right here is going to change from a less than to a greater than. So you cannot forget to change the symbol. All right? You cannot forget to change the symbol. That's the golden rule. I'm just going to do, let's do another one. It's a little tougher. Let's see what we got. Is there no multi-subs here? There should be a multi-sub. Or is there not in this section? Let's just do number 16. No, let's do one that you don't actually flip. Oh, okay, so number 11. That's negative 90 is greater than or equal to 4t. Okay. So I'm going to divide by 4, divide by 4. This is going to be 22.5, negative 22.5 is less than or equal to t. Now, I just want to point out, I could also switch this around. So t is less than or equal to negative 22.5. If I'm going to swap places here from t to going there and then the number is going there, then I have to swap the thing here. That's another reason why you might swap it. And the key thing here is that maybe the multiple choice answer doesn't look like the top one, but the bottom one is there. So you have to really pay attention to that even though the top one here is the correct answer, in multiple choice, it might just look like this. So make sure you're taking care of this. Now it's page 308. Let's go on to the next, which is page 314. Let's see. Oh, is this multi-sub now? Which is what I was looking for. Yeah, okay, so let's do a quick multi-step one. What's a tough one? Let's do number 20. Oh, wait, 20 is a no solution. Let's do, oh, well, they're annoying. Oh, let's do number 19. Let's do number 19. So we got 3 times s minus 4, parenthesis, is greater than or equal to 2 times s minus 6. S minus 6. Okay? So we're going to do distribute here and here, and this 2 is going to distribute here and here. So we got 3s minus 12 is greater than or equal to 2s minus 12. Let's see what we could do. I'm going to minus 2s here, minus 2s here. We got s equals negative 12 is greater than or equal to negative 12. Since I subtracted, key thing, I subtracted 2s. So that does not cause it to flip. Subtracting does not cause it to flip. So plus 12, s is greater than or equal to 0. 0 is a perfectly fine number. It could be an answer. So s is greater than or equal to 0, and you're done there. So that's a multi-step inequality. Let's go on and on to the next one. So this is 314, 326, which is this verbiage? What is this? Compound inequalities, of course. So let's do the compound one. Oh, the compound inequalities. So compound inequalities is actually really important because they're not simply just bigger multi-steps. So compound inequalities, you have 2 versions. So I just want to go over that. So this is page, what is page is this? 240, 320, 326. Numbers. Let me just check this off. Did I skip one? Hopefully not. Number 9 and 19 on. So I'm going to do one and version, one or version. So let's do an and version, which is number 11. So negative 1 less than or equal to negative 4m, which is less than or equal to 16. Okay. So what's really important with the and situation is that you got to split it up into 2 questions. So you got negative 1 is less than or equal to negative 4m, and negative 4m is less than or equal to 16. Now you just solve it like normal. Divided by negative 4, divided by negative 4. So you got 1/4 is, notice I divided by a negative, the rule still stands, so it's going to flip into a greater than or equal to m. And then here is going to be a negative 4. I'm going to divide by a negative 4, divided by a negative 4. M is less than or equal to negative 4. Again, I'm sorry, I made a mistake. Because I divided by a negative 4, I got to flip that symbol. Let me just, good thing the video stopped, so it didn't even show my mistake. So because it's negative 4, and here. Now, here's a really important thing, guys. You might not see your answer in 2 separate things. You might see it like this. Negative 4 is the smallest thing, right? So I can write this as negative 4 is less than or equal to m. That's the same thing between up and down. So it could be written like this. Negative 4 is less than or equal to m, which is less than or equal to, just remember this is the same thing as m is less than or equal to 1/4. So which is less than or equal to 1/4. So your answer could look like this, even though these 2 are a correct answer and these 2 are a correct answer. It's a multiple choice test, so maybe this is how your answer looks. So you might get the answer, but if you don't know if it looks like this, you're still guessing, and that's not good. So that's what the and statements. The or statements are much easier. They're already split up, and there's really less confusion about it. So I'm going to look for, give me an or. So let's do number 15. Number 15. So let's do number 15, which is 2r plus 3 is less than 7. Less than 7. Or negative r plus 9 is less than 2. Negative r plus 9 is less than or equal to 2. Okay? So number 15 on the same page, on page 326. So good thing about or statements are they're already split up. So I'm going to solve them separately. -3, -3. 2r is less than or equal to 4. divided by 2, divided by 2. R is less than or equal to 2. Over here, minus 9, minus 9. Negative R is less than or equal to negative 7. Divided by negative 1. Again, I do not like negative exponent or negative variable, so I divide by negative 1 to get rid of it. That is going to be R. Notice I divided by a negative, so I got to flip the thing. Is greater than or equal to 7, positive 7. So your answer here is R is less than or equal to 2, or R is greater than or equal to 7. Typically, your answer would look like that. Maybe this one is on the left, this one's on the right. It doesn't really matter. It still sends the same message. Okay, so that's that. So we cross that off. 326, 335. Oh, 326? Yeah, so 335. Why does it not delete the thing? 335. Absolute. Excuse me, absolute value. So absolute value at page 335. So absolute value, you get two answers. So I'm going to do a very simple one. Absolute value of x equals, I don't know, this is number 436. So you got two answers, both the negative version and the positive version. So x equals 36 and x equals negative 36. Hey, you're already done with that one. Now, something like number 14 is where you have to actually do some math. Actually, let's do number 13. So number 13, is that in the camera? Good. Is absolute value of 2d plus 7 equals 11. 2d plus 7 equals 11. So you're going to split it into two questions. So you have to do 2d plus 7 equals positive 11. That's okay. But you also got to go 2d plus 7 equals negative 11. You have to do both every time. Make sure you know how to set that up, or you're just going to get it wrong. Minus 7, minus 7. That is 2d equals, so 4. Divided by 2, divided by 2. D equals 2. Yeehaw. Here, negative 7, negative 7. 2d equals negative 18. Divided by 2, divided by 2. D equals negative 9. D equals 2. D equals negative 9. And the thing froze, so let me just fix that. Okay. So D equals 2 and D equals negative 9. Notice that I did divided by 2 on both sides. Cross this out. And then negative 18 divided by 2 is negative 9. Okay. Now, let's say if you had a situation where you had something outside its absolute value first. So like number 23. That's 20. Number 23, which is absolute value of r is x minus 1 plus 5 equals 2. X minus 1 plus 5 equals 2. What you have to do first is get the absolute value bars by itself before you split it into two things. So you got to do minus 5 minus 5. Absolute value bar is x minus 1. Absolute value bar equals negative 3. Now, so this one's funny because this one, you cannot split into two things because you have a negative here, and absolute values can never be negative. So right here, the situation is a no solution. But I'm going to make one up, so let's call this 23.2. That is a solution. So I'm going to do x minus 1, absolute value bars minus 5 equals 2. So I'm going to do plus 5, plus 5. Now if x minus 1, absolute value bar equals 7. So now I'm going to do plus 1 on both sides. So, well, before I do that, I'm going to split it into two questions. X minus 1 equals 7, and x minus 1 equals negative 7. Plus 1, plus 1, plus 1, plus 1. X equals 8. We're happy with that. X equals negative 6. We're also happy with that. So these are your two answers. And I call that 23.2 just to mix. I just wanted to do an example like that. don't worry about this much too. Don't worry about this too much. But you should know that if you have an absolute value bars and it equals a negative, you have some. You're making a mistake somewhere. Okay. Unless the option is no solution, which then yes, it is a no solution. We're nearing the end, at least for my fifth period class. So page 351. Let's get to that, which should be 351, which should be more absolute value. Oh, graphing linear inequality. So this one is a fun one. So graphing linear inequality. So let me take one that's simple. No, you could check for solutions. We don't check it for solutions, so yes or no. I want to do one that is, so let's do number 19. Y is greater than or less than 3x plus 5 is less than 3x plus 5. Okay, so I got my handy graph paper here, and I'm just going to rewrite the answer here, or question here, 3x plus 5. Hey, notice this looks like y equals mx plus b. We did y equals mx plus b probably like 20, I don't know how long ago anymore is. So what is my b here? My b is 5. What is my y here? My slope here? My slope is 3 over 1. I changed it to a fraction to make it easier to illustrate that I'm going up and then right. So with that in mind, let's go. So my y-intercept is 1, 2, 3, 4, 5. So I start at the y-intercept 5 plus, and I'm going up 3, 1, 2, 3, and right 1. Go up 3, right 1. Now remember, the opposite of up 3, right 1 is down 3, left 1. So we go 1, 2, 3 down, left 1. 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 All the way down. And hopefully this is on the camera. Oh, got a little off. Okay. Now I'm going to connect the dots. Nice straight line from me. Now here's the thing that makes it an inequality. We have to plug in and check and test is 0, 0 solution. So we're going to plug in 0, 0. So y here is 0 is less than or equal to 3 times 0 plus 5. Well, 0 is less than 5. Is that true? That's a yes. That is true. So because yes is true, we're going to shade towards the 0, 0. So we're going to shade this way. So we're going to shade this way, okay? So this is our answer right here. You need to shade it in, or you should recognize it should be shaded in that way for that type of question. Our next one should be the next section, I believe. Where is it? That's 351. Okay. Fifth period, the next section is the last section that you'll be tested on. So we'll go to page 372. Because we did this as together. This is graphing inequalities of linear systems. So let me see. I don't want to check solution. I want to give me a question. Okay, so let's do number 13. So number 13 on page, this is on page 372. Whew. So page number 13 is going to be y equals negative x plus 4, and y equals 2x minus 8. 2x minus 8. Can't draw 8 right now. I guess I'm really tired. Minus 8. So how are we going to do this? Well, we're just going to draw two lines. It's really easy, and see where they crisscross. So I've got my handy dandy paper again. Let's send this over. So then I'm going to rewrite the question here. Y equals negative x plus 4. And then y equals 2x minus 8. So I'm going to graph each one separately. So let's do the first one. Y equals x negative x plus 4. My b is positive 4. My slope is negative 1 over 1. So if it's 4 up, 1, 2, 3, 4 up, put a dot here. And I'm going down 1, right 1, down 1, right 1, That's the same as going up one, left one. So down one, right one, down one, right one, down one, right one. Continue on going. And then it's going to go up and right. Connect them dots. Not my best line, but whatever. Okay. Down and right, up and left. Now let's do the other one, which is y equals 2x minus 8. So b equals negative 8. M equals 2 over 1. So that's up 2, right 1. So I'm going to draw a negative 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. And go up 2, right 1. 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 I could keep drawing, but I know how this is going to go. Because there's only one thing I care about is where these two crisscross, which is right here. And that is that comma, 1, 2, 3, 4. So that's 4, comma, does it go up or down? 0. So your answer for this one, oh, and it stopped working, my camera, sorry about that, is 4, comma, 0. Let me just re-illustrate what I did. Start at negative 8. Then I go up to right 1, 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 yada, yada, yada. And what I really care about is where these crisscross, which is at 4, comma, 0. If you're you're a fifth period student that is watching this, your review is pretty much over. We've gone over everything that should be on the test. Hopefully I didn't miss anything. For my third period class, stick around. We still got a little bit more. We're going to do one elimination, one substitution, elimination by multiplication, and one graphing inequalities, and then we're going to call it a night. At least I will. I don't know when you're watching this video. So let's do page 381. I believe this is substitution. This should be fresh in our minds. But I remember not everyone did so well on the test, so I would pay attention to this regardless. So, page 381. 381. Let's see, let's pick a clean one. So this is which one? Substitution. So I'm going to do number 6. So number 6. So that is 4x minus 7y equals 10. And then y equals x minus 7. So how are we going to solve this? Well, if I knew that, let's say if I told you that y equals 2 or something, I would know I would replace the y with a 2. But I don't know that y equals 2, but I do know y equals x minus 7. So I'm going to replace that with x minus 7. So that's 4x minus 7, parenthesis x minus 7, equals 10. Distribute. 4x minus 7x plus 49 equals 10. Let's combine like terms. Negative 3x plus 49 equals 10. I feel like I've done this problem exactly before as homework or something along those lines. Minus 49 minus 49. Negative 3x equals negative 39. Divided by negative 3, divided by negative 3. X equals 13. Look at that. We're not done. Isn't that crazy? We're not done here. Because what we got to do is take it and plug it back into one of the originals. Now, hopefully you got good eyesight. You could tell which one is easier. Y equals x minus 7 seems really easy. Y equals, now I know what x is, which is 13. I'll put it in parentheses to indicate I substituted, minus 7. Y equals 6. So your final answer is 13, comma 6. Look at that. Was that easy? You should feel that it was easy. All right, let's go to the next section. I got to go home soon. So let's go to the next one, which is, what level is that? 381. Okay, so let's go to the next one, which is 389. So page 389 has to be elimination. So let's just line this up and finish this off. Remember, your goal is to make one of the things 0. However that is, so like number 7 is negative 9x plus 4y equals negative 17. And then 9x minus 6y equals 3. Oh, this is not even, not gonna fix the camera. Minus 6y equals 3. Oh, never mind, it worked. Okay, so, real easy. We gotta look at this and say, well, does one of these letters match or one of these variables match in terms of numerals, the numbers in front? Hey, well, look at this over here, 9 and negative 9. So what do? I put a big plus sign because I want to get it to 0. If it was positive 9 and positive 9, I would subtract. If it was negative 9, negative 9, I would subtract. But since it's a negative and positive, I'm going to add. Negative 9 plus 9 is 0. X. 4 plus negative 6 is negative 2y, because that's 4 plus negative 6. And 17 plus negative 17 plus 3 is negative 14. I'm going to divide, oh, well, first I'm going to redraw this without the x, so negative 2y equals negative 14, divided by negative 2, divided by negative 2. Well, hello there, y equals 7. So then we're going to take this and plug it into one of the originals. Let me plug it into this one. There's more smaller numbers. So that's 9x minus 6 times 7 equals 3. Well, 9x times x times 7, I must be really sleepy, it's taking me a while, negative 42 equals 3, plus 42, plus 42. This looks familiar, 9x equals 45, divided by 9, x equals 5. So x equals 5, my camera pauses in the most important part, but that's okay. 6 times 7 is 42, negative 42, right? So plus 42 on both sides, cross this guy out. So you got 45 divided by 9, x equals 5, y equals 7. Your answer is 5 comma 7. Okay, check that off. 396, my bad, 396. We're going to do one where you have to multiply first. The reason we multiply first is because it's important to know that if you want to eliminate, you have to have something to match. If you don't have something to match, you make a match. So I'm going to do let's do one where we have to subtract. So let's do number 7. So that is going to be 8x minus 5y equals 11. And then the other one is going to be 4x minus 3y equals 5. 5. Okay. Alrighty. So what we're going to do here is crack my knuckles and then say, 8 and 4, 5 and 3, they don't match. That's a shame. So what can I do? Well, hey, 4 goes into 8 twice, so I can multiply this whole thing by 2. Why did I multiply this thing by 2? I know one of you are asking. It's because 2 times 4 equals 8, and I want it to match. So I'm going to multiply this by 2, multiply this by 2, and multiply this by 2. And I'm going to draw it over here. So that's going to be 8x minus 2 times 3 is 6y, and 2 times 5 is 10. I'm going to redraw it so the other one's on top because that's a bigger number, minus 5y. Actually, it doesn't really matter, 11. And I'm going to redraw here, 8x minus 6y equals 10. And now I'm going to take a big minus sign and subtract because my goal is to make this 0, so 0x. Negative 5 minus negative 6 is the same thing as negative 5 plus 6, so that's just a positive y. And 11 minus 10 is going to be 11 minus 10, that's 1. This is simple math. So you end up getting y equals 1. I'll just rewrite it here, y equals 1. Then we're going to plug it into one of the originals. You want to plug it into one of the originals, not the new one you fabricated. Minimize this problem. This is harder than this. So let's plug it into the smaller one. So 4 times 1 minus 3y equals 5. Well, look at here. 4 minus 3y equals 5. Hey, minus 4, negative 3y equals, wait a second. Did I make a mistake? Am I going too fast for myself? It's supposed to be a fraction? Oh, is anyone here? I'll say no one knows. Did I make a mistake? 1, if I plug in a 1. Oh, now I see what I mistake. This is a y equals 1. Where did I plug in that 1? Not in the y, in the x. Well, that's silly. So we're going to restart. 4. Now this is x minus 3 times 1 equals 5. Now I just feel silly, but that's okay. Important thing is you find your mistakes. Maybe you do something on the multiple choice and you're like, wait a second, none of these choices are the multiple choice answer. So then, hey, wait a second, that must mean, cross this out, that must have made a mistake. So hopefully you can see that too without making an error. So x equals 2, so your point is 2, 1. And you can always check by plugging it back in here. So 2 times 4 is 8, 8 minus 3 is 5, cool. 2 times 8 is 16, 16 minus 5 is 11, awesome. So you can always check it by plugging these two answers back to the original. I'm going to skip page 396 of special cases, which is just more review. What I really care about is page 406, graphing a system of inequalities. So this is where we double shade. So this is page 406. So let's just go to page 406. No, page 417 actually. So right to page 417. I'm going to do a problem that's really not that tough. So this is number 14. Number 14, so this requires us to graph correctly. Let me just write it here so it makes it easier, because hell, I'm just going to do all my graphing here anyway. So I have y is greater than or equal to 2x plus 1. And I also have y is less than negative x plus 4. So this should look familiar. This is like what we graphed in the other section, 0.1, 6.1, whatever. So how are we going to solve this? Well, it's very easy. So what we're going to do is do y is equals mx plus b. So we're going to identify our y, and we're going to identify b. So let's do the first one. B is 1. M is 2 over 1. We've been graphing forever now, so hopefully you get it right away. So b equals 1. I start here, not here, please, not on the x-axis. Please start in the correct axis, which is the y1, up to right 1, up to right 1, up to right 1, up to right 1, and then down to left 1, down to left 1, down to left 1, down to left 1. And then we're going to make a nice straight line. A nice line that's maybe straight. Next one, we're going to do m. Let's do b first. B is positive 4, and m equals negative 1 over 1. So we're going to start 1, 2, 3, 4 up. And we're going to go down 1, right 1, down 1, right 1, down 1, right 1. And I go up 1, off 1. Key thing here to notice is that it don't really matter. Like after I see where they crisscross, that's where I really care about. Where they crisscross is where I care about, because now I could just stop drawing. I should make the line really long so it can shade in the proper point. Okay, so we're still doing the test for 0, 0, okay? So notice this is on the right and this is on the left. So we still plug it in 0, 0, see if it's true. So let's do the first one. So y is greater than or equal to 2x plus 1. Is that on the camera? Good. So that's 0 is greater than or equal to 0 plus 1. 0 is greater than or equal to 1. Is that true? Is 0 greater than 1? Absolutely not. So this one, which was this equation right here, this is a long first line, I'm going to draw arrows away from it. The reason I draw arrows is because if I shade it in, I might get myself confused, and that's awkward. So the next one, blah, 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 is I'm going to plug in the next one for 0, 0. So y is less than or equal to, or less than negative x plus 4. I'm just going to cut to the chase. 0 is less than 4. Is 0 less than 4? Yes, it is. So now this line, this left to right line over here, is going to go towards 0. And since it's towards this way, I'm making arrows this way. So I got to see where the arrows overlap. Well, this arrow is going this way, and this arrow is going this way. So this is the overlap. So I'm shading this in. That's it. So we shaded. We're done. We're happy. It's shaded. Only one section gets shaded, so you have a choice of four. Maybe this make a good multiple choice question. I don't know, but there's only one way you're going to shade it, and it's going to be this way. This is the correct way. You have to test each one individually, and then do the shade the one that they agree on, which is this section. Okay, guys. I hope this video helps you. I hope you guys watch this maybe to the full extent. Maybe when you're, I don't know, doing something else. Maybe when you're just studying and you just need this in the background. I hope this, guys, this helps you, and I want you to do well on your midterm. So it's really important to me to make sure that you do well. That's why I make these videos. I care about your grade, I care about your health, and I care about you. I know you guys have a lot of studying to do, so hopefully this video, you could find it on your time to do it. Otherwise, I'm here every lunch except Wednesdays. Forgive me for that. I really care about you guys. I just want you to get this done and do it right, okay? So with that in mind, I'm signing out. I don't know, like, subscribe, and all that. Have a wonderful night and have a wonderful midterm.